Welcome back. This is Richard Rahn with the Leonardo Group, and what we're looking at here is the summary results screen for an Excel-based simulation tool called Flow Simulator. And in a previous video I showed you how to run the simulation model using this tool and how to get the data into the model, what the model is actually looking for. And in this video what we want to do is run through various scenarios of improvement. This particular line, I happen to know, was designed for 456 units per day, or per shift in this case, one shift. And you can see here on the screen, completed orders, we're only getting 229. So what I want to do in this video is walk through the kind of analysis process we might do to improve the performance of this design, step by step, and resolve bottlenecks and get closer to that desired volume of 456 units per shift. So what we're going to do here is start with the obvious. Before we get into the actual resource statistics that you can see down here and try to identify what the bottleneck resources are, what I want to do first is make sure there aren't any obvious errors in entering the data. And I happen to know of a particular area that might be problematic. So what I'm going to do here is click down at the bottom of the screen and go to the data separate Excel worksheet, the data worksheet. And I have some suspicions we might have a problem with travel time. So what we see here are all the locations in the model, including wiring workstation 1, going to wiring workstation 1 IPK, that's a buffer, and then wiring workstation 1 IPK goes to wiring 2, etc. And it looks to me like we've recycled this worksheet from a previous simulation, but forgot to update the travel times. And remember, these travel times are going to be additive. They're going to add to the actual cycle time as the model's executing, and so they're going to have a pretty significant impact on the model performance. And what you see here are times that are, 15 seconds, 0.4, 20 seconds, so almost a minute in this case. So this is adding a lot of time to the model that we don't want. So what I'm going to do, since in this case, since we know that this line layout is fairly compact and those times are not really going to be significant, what I'm doing here is just replacing all these for the time being with a small time value. And we can go back, and if we have better data later on, we can refine this. But for now, I'm putting in 0.04 as the travel time and operator travel time. And then I'm going to click on Save. So what we'll do is we'll go back to the model, and I'll go to Add-ins. Kaplan Business Group is the creator of this tool, and click on Simulate. And here we have our control panel, and I'm going to disable simulation just so it runs faster. And remember, we had a quantity of 229 in 435 minutes, 30 minutes of warm-up, so let's just go ahead and run. And this runs pretty fast. This is a fast computer. And once it gets going, and you can see this up at the top here, these are simulation minutes. And we're going to run this for 435 minutes. This should be done in just a few seconds. And then we can see whether or not that had an impact and improved the performance. And the suspicion is that it will. So we're getting close here, and there we go. So 233, up from 229. So not a dramatic improvement, and that maybe tells us that there's some other problems with this in terms of improving that throughput. But this was something that needed to be done. So I'm going to pause right here, and then we'll go on to the next potential improvement by looking at these resource statistics down here at the bottom. Okay, so we fixed one problem that we know about. Now let's take a look at the resource statistics and see if we can identify what some of the bottlenecks might be to improve this performance of 233 to a more satisfactory result. And so I'm going just down the list. I'm eyeballing here. What I'm looking for is percent busy and percent blocked or waiting, and to get some idea of where the potential bottlenecks might be, and then we can just address them one by one. So here's a mold process, and I've got 88% busy, so that's pretty fully occupied, and then another 12% blocked. So that might be one worth looking at. So what we're going to do is go back to our data Excel sheet and look at mold. And what I've clicked on here is process times. Let's start with that. And I'm scrolling down the list and looking for mold, and here it is. And one thing I notice is that there's machine time plus labor time, and both of those will be added together. They're not considered to be done in parallel, and it looks like there's some substantial times here that may be causing that to be a bottleneck resource. So one of the things I'm going to do to not make this additive, just as an experiment, I'm going to take out the machine time. I'm just going to put a very small value in there. So now the machine time is not having an impact on the simulation results. And then what I think I'll do, instead of changing these times, I have no reason to know that these times are wrong, I'm going to add another operator. We might be understaffed in this area. So I'm adding 2 people here instead of 1. So number of operators 2. And then I click on Save, and then I go back to the control sheet, add-ins, simulate, and let's just run it again and see what happens. Let's see if we get an improvement. Remember, previously we were at 233 units, and it's running, it takes about 10 or 15 seconds to run through the 435 minutes in simulation time. That's the beauty of using something like this. And when it gets to 435 run minutes, we'll check our results. Okay, here we go. I go back to summary stats, and it jumped up to 238. So a little bit of an improvement, but not huge. So what we need to do then is keep on digging and go through an iterative process and keep on making improvements until we get closer to where we want to be. Okay, so we're going to continue and proceed in a logical way to improve the performance of our simulation model. And last step I'll demonstrate to you. Of course, this would go on for some period of time of analysis and tweaking. But what I'm looking at here is the resource stats, and we're currently at 238 units, which is substantially below the design performance. So something's funny here. So I'm looking at the resource stats sheet, and I'm just scrolling down and looking for something, and something catches my eye here. That's these here. We have 4 test stations, looks like, but that rings a bell. That doesn't sound right. So I'm going back to our source document, which was the line design calculations, and follow me over here. We've got the test process. If I look down here to number of test stations, we needed 6. So that tells me there's an error here. So possibly. So I go back to the input sheet, our data sheet resources. The output looked like it said 4, and sure enough, there are 4 here, and that is not correct. So I'm adding 6 here with a capacity of 1 piece per. So let's save that, and let's do one more run here and see if that does anything to our line performance. I suspect that it will. So add in, run, simulate, and run. As I mentioned earlier, I'm turning off the enable animation, but the enable animation can be a good way to debug your model as well, because you can run it very slowly. There's an animation speed control, and you can run it slowly and actually see with a color-coded method the movement of products and see where the potential bottlenecks are visually on the layout that you see here on the screen. Right, so we're at approaching 400 minutes. Well, zooming right by it. And we are done, and let's see what kind of results we achieve. So summary stats, we're now at 288. So that's a pretty good jump, 238 to 288. But needless to say, we're not done yet. So more to go, but the process we would follow is, as we've discussed, what we're looking for is blocked stations, stations that are waiting, and stations that are simply overloaded with too much work. And we just proceed step by step, and hopefully improving those at each step. We can keep track of what we're doing, by the way, just by adding a worksheet here where we're keeping a log of what it is we're actually improving.